Okay, so in this video, we're going to teach you about input and output to terminal commands and how you do some really cool things with redirection. So one of the things that's probably been a little frustrating about our class so far, especially that last video I just showed you a bunch of commands, is not only are there a ton of commands to use, but each one has its own set of arguments and flags that you have to look up in the man page so that you can remember how to use them, and nothing is consistent. However, I have great news. Input and output are consistent across all commands, which is very, very nice. So Unix thinks about, which again, Unix started Linux. Unix brought this idea of having 3 streams for input and output. Streams are places to read data from and to write output to. So there are 3 standard streams: standard in for standard input, standard out for standard output, and standard error for standard error. You've already seen these in Java programs for the most part. Whenever you do system.out.println, that's telling the Java program to print to standard out, which when we saw in our terminal was just the terminal screen. And then similarly, the input is like the keyboard input from the user, but that's actually going to be slightly not true. It doesn't necessarily have to come from the keyboard. We'll actually talk about that later. But by default, they're all coming from the console. They print to the terminal and they read user input from the terminal. But Linux allows you to change where these streams are kind of pointed to. So you can do some really cool things with these operations. And so I kind of have a visualization of this here. Any process, any process or any command that you run has something like standard in that reads from and then prints out to either standard out or standard error, which default to the terminal. Let me show you why understanding this can be useful. So what would happen if I try to say I wanted to run my Java program? So Java, well, let's not do the Java one yet. Let's take grep berry fruits.txt. So say I wanted to save all of those berries to a new file so I could remember all the berries. Now, what I could do is I could copy and paste, copy everything, open up Vim, paste, and save, but that's really tedious. So let me type out the command, and then I'll explain what it's doing. Berries. So what I've just done, the first part of this command here is just the plain old command we ran before, grep berry fruits.txt. Then afterwards, I use this little waka. Sometimes people call those wakas because they look like Pac-Man, waka, waka, waka. So I use this little right waka, and then I put a name of a file afterwards. What this does is this tells the program to save the output to berries.txt instead of printing to the terminal. So it sees berries.txt here. You can cat it, and you'll see it's just all the berries. Now, here's the really clever thing about how this works. Let's try doing this with my hello world program. So hello world.java. So notice I'm going to be running it with that new Java way. And then let me save it output to out.txt. And so it is doing something and that paused. So it didn't print anything, but it's pausing for me to type in user input. What's happening when you use this waka and pointing it to a file is the Linux is essentially tricking your program to think that when the program thinks it's printing to system out, it's actually writing to a file. So what it does is it actually changes what the standard stream is behind the scenes. So the program just thinks it's printing to the console. But really, because you called the command in this way, the console standard out has been swapped with writing to that file. So it's pausing for input right now because the program asked for system.in. So I'm going to type in my name again, Hunter, and then I'm going to type in my password, I love dogs, and then it doesn't print anything else out. But now I can cat out.txt, and it shows all the things printed to system.out. Now notice one thing that's probably a little bit weird is before when I ran this program, let's see if I can scroll up. We ran out of it. Before when I ran this program, you saw that like my name and my password showed up right next to the prompts. Well, that was because it was printing to the console and I was typing in the console. So since all that was happening in the same place, they were together. But now because it's printing to the file and it's still grabbing my input from the console, they're now in separate places. So you don't see what I typed anymore, which can sometimes be just a little confusing. Now, you can also, you're not just limited to saving standard out to a file, you can also change standard in to read from a file instead. So what you could do is you could do java hello world.java, and then instead of using this for output, the right waka, use the left waka for input. So maybe what I'll do is I'll input fruits.txt as standard input for this program, and then it's going to run. So notice this program still prints to standard out because I didn't redirect standard out, and it prints on the terminal. And again, it doesn't print what I'm actually typing in, the enter your name and enter your password, because it didn't ask me to type something into the console. Standard in is now attached to that file, fruits.txt. So in our program, when you say hello world, in hello world.java, when you say input.nextLine, it just grabs the next line from the input. And this input was buffered with all of fruits.txt, so it grabs the first line. And so that's why it says my name is Asai and my password is Cloudberry. Because if you look at the first two lines of fruits.txt, sorry, I forgot the number 2, fruits.txt, it's Asai and Cloudberry. Pretty cool, right? Now, there's also one for standard error. Standard errors where errors get printed, like exceptions or compiler errors or anything like that. It's just like standard out. It's actually a little confusing because it goes to the same place as standard out by default. But let me go ahead and add this compiler error here. So now when we run this, say java hello world.java, we get an error. But now say you wanted to save that error to a file. So let's say save it to out.txt. Maybe I'll save it to errors.txt. It's still printed to the console. And the reason is these errors aren't getting directed to system out, they're getting directed to system error. And because we told system out to go to the file, it did that, but we never did anything with the standard error. So there's kind of a weird symbol for this one. We use to waka to redirect standard error. And now you have this file called errors.txt that has those errors saved in it. So usually when you think about these redirections, you have multiple places you can read from or write to, and it's all about writing the command to get input or output to the files that you want or need. We'll see later in this video how to do both redirecting input and output for the same command. We'll get there. But I want to talk about a few other things first. So one thing I want to talk about is that a lot of programs, particularly grep, are kind of built to work in multiple scenarios. So for example, if you type grep berry and then hit enter before typing in a file name, well, because you didn't pass in a file, grep is programmed to now read from standard in instead. And so now when you type in something like hello world, my favorite berry is strawberry, it prints out any lines that contain berry, but does not print out lines that don't contain berry. So grep is now reading from standard in. Now, it's important to remember that in these, one of the most important distinctions in this class is the difference between standard in and a command's parameter. A parameter is an argument that you give on the command line. So like in my example here, I use ls_dir1. dir1 is a parameter you're passing in, and it does not come from standard input. It comes from what you typed into the shell before you ran the command. Remember, standard input is the thing that feeds into the command while it's running. So the standard input comes from the user, either from a file or from the console. And so when you type grep as pattern and then nothing else, then it runs. And I have a note here. I didn't explicitly show you how to stop Usually when something's reading from standard in and you want it to tell it you're done, Control D does that. If you type Control D, that's the end of input. So that's a really important distinction, the distinction between an argument or a parameter and standard in. Two different places that could be read from. Okay, so I want us to do, I showed you these. I want us to do a practice problem. Write a command to store all the lines of fruits.txt that contain the letter A into a file called a.txt. I'm gonna go ahead and pause and let you try this out. Okay, so let's start by just doing the command to find all of the fruits that contain the letter A, and then let's talk about how to save it to a file. So we actually saw how to do this earlier, but it's important to see how you could do the same task in slightly different contexts. So you can use the grep command, and you want to search for the letter A. And remember, you can leave off the quotes or use single quotes, but I always use double quotes. A, and then I want to search for fruits.txt. I found all the ones with A. Now I want to save that to a file. So I'm going to use this right waka, this arrow, to say take your standard output and please save it to a.txt. And so whenever you get stuck on trying to solve one of these problems, I really encourage you to try to solve it in parts. Try to solve just the part of what is the task trying to ask you to do, and then how do you save it. It might also ask, if we're trying to do both input and output, that can get more complex, so on, but this is the right way. Now here's one thing that I want to make sure that we separate. Some of you might have tried to think ahead and be like, how can I do both standard input into the program and standard output out of the program redirected in the same command? In this case, you don't want standard input into this grep command. The reason is, like, some people might think, like, what if I wanted to tell it A is the thing it's searching for by passing that into standard input? Well, the pattern is an argument. It's not read from standard in. The only thing grep might read from standard in is if you don't pass any file names, and then it's just going to print out whatever it reads from the console. Notice grep isn't doing anything fancy necessarily with reading from standard in. Our program reads from standard in. It just opens up a scanner to system.in and then reads from it. Grep does the same thing, but it's not written in Java, but it's essentially the same idea. Standard in gets a system.in. When we create the scanner to it, is going to read from whatever system.in is. And your command, when you change system in, kind of goes behind the scenes and tricks Java into thinking that what it's reading from system in is from the user, but it's really from a file, which is just a really nice way. Now, importantly, if you think of our hello world.java, the standard in comes from reading from a scanner. The arguments to the command come from string bracket bracket args. So this whole time when you've been writing Java, you've been writing string bracket bracket args in your main methods. That's because Java was designed to take command line arguments. So let's try this. I'm just going to go through, and for each string arg in args, I'm going to print out system. That's a really big tab. System.out.println arg. Okay. I'm going to save this. I'm going to run it. So if I do this, just run it like that. Oh, I forgot that I have a semicolon still missing here. If I run this, it doesn't print anything special because I didn't pass any other command line arguments. So if I pass in A, B, C, it's going to print out A, B, and C first, because the first thing we do in hello world.java is go print out the arguments. So the arguments that you pass on the command line just go straight to the program. And this is how they write programs like CD or LS that take all these extra arguments. They just have an array called args that they parse through and figure out what you tried to do based off what arguments you passed in. Let me show you how grep knows the difference between reading from standard in versus reading from a file. So I have a file here called simplegrep.java, and it is a very basic implementation of grep. Ignore the main method for just 1 second. The grep method is fairly straightforward. It takes a string pattern and a scanner input and just loops through each line. And if that line contains the pattern, it prints it out. Very, very simple grep. You can see here that if you run java simplegrep.java and pass in berry and fruits.txt, it will go through and print out all of the fruits that contain berry. And you can also leave out the name of the file, and it will read from standard in. I can do hello and goodbye and strawberry. It'll print that stuff out. Okay. And just like regular grep, this grep can also take multiple files. So I can look for fruits.txt and hamlet.txt, and it'll print out all of the berries. Apparently, Hamlet is not a fan of berries. There's no berries in there. So how does it actually do this? Well, that's just what my main method does. My main method is a little complex, but it's doing one task. It's essentially looking at this string bracket args and making sure that, or trying to figure out how you're calling it. So args of 0, the first element in the array, with how we defined how grep works, is always going to be that pattern. So I just grab args of 0, it's just an array of strings. Args of 0 is the pattern. And then if the length of those args was 1, I know the user didn't pass a file to me to search through. So I make a scanner to system.in and then grep on that, call that grep method that takes a string and a scanner. Now, if I want to, if in this else condition, I know that they passed in additional arguments. They didn't just pass in 1 for the pattern, they passed in more. And if they pass in more, then I'm going to loop over all of them, starting at 1, going to the end, grab the file name, make a scanner to it, and then call grep, passing that in. Now, the real grep has a lot of extra fancier things like color output and nicer formatting of the results, but this gives you an idea that none of this is magic. All of it is just if statements, where they wrote code, and the code can be pretty gross sometimes, especially in those like a language like C, to look at all the arguments and figure out what you're doing in just a big if-else statement based on what you passed in. So that's just one thing to remember, is that all of these commands we're learning are actually just programs, just like this Java program. They just are usually a lot more complicated than this. And to get errors, it's the exact same thing. I said, hey, if args.length is less than 1, meaning the user didn't pass in a pattern, I throw an exception. And that's how you can crash if someone called your command the wrong way. So this is essentially how you can kind of write your own commands, because the commands are just programs. Okay, so now I've shown you simple grep. Now I can finally show you the last thing I'm interested in showing you, which is how do you do both redirection of input and output in the same command. So the syntax for this is, it's a little weird the first time you see it. It has to go in this particular order, but it's definitely just composing the 2 independent things we just learned. So you type java hello world.java, and you start with your input. So you use that left waka, and I say, okay, maybe I'll do fruits.txt. And then you do your right waka for output. So then right waka, and then let's call this out3.txt. I forgot which out we're on right now. And now when I cat out3.txt, it's going to be using those fruits as the inputs. So it's using both. Standard in is hooked to fruits.txt, and standard out is hooked to that out3.txt. One weird one that you don't see as often, but I thought I should at least just mention so that you know, there is one of the sometimes annoying things is that standard error is different than standard out. So there's a way to make them go to the same place. You can say java hello world.java, and then you use this weird syntax, waka to &1. And I have more examples of this on the slides for today. Oh, sorry, I had a typo. It's 2 first, 2 waka, and then &1. But the slides are always correct. I never make mistakes in the slides, I promise. So that makes them go to the same place. So now standard error and standard out are the same. And you could still do piping with that. It just looks a little, like, you could still redirect it to another file. It's just the syntax can be a little strange. Now, the last thing, so this is not an important point, I'll just mention, but the one that is important is when you run a program like Java hello, let's run this again, Java hello world, pipe in fruits as the input, and then out.txt is the output. You have to be a little bit careful when you do output redirection. So when you use this single waka in out.txt and run this, the semantics of this say, well, if the file does not exist, it's going to create one and the contents will be the output. If it does exist, it's going to overwrite it. So I don't remember what I had in out.txt before, but now I've out.txt, but now I've lost it, because if I pipe some new, or if I redirect some new output here, so like grep berry fruit.txt into out.txt, now when you cat out.txt, it's the berries thing. So you have to be a bit careful here because it can overwrite files. A very dreadful thing you could do would be something like Java hello world.java, pipe into hello world.java. And now it's going to overwrite its own source code with the output. So be very careful with how you do this. One trick to sometimes save you, it's not going to save you, but one thing if you don't want it to overwrite, if you use two wakas, it's going to append to the file rather than overwrite it if it exists. So now if I do this, if I run this Java command and do double wakas, and then I do tail out.txt, it will show you the end of the berries because it didn't overwrite those. It just appended to them with the text of that program. So again, what have we learned in this video? We learned that standard in, standard out, and standard error are standard across all programs. They interact with system in, system out, system error if they're in Java. But you can change what those are connected to using these redirect operations. Now, in the next video, we're going to show you one more type of redirection that lets you connect programs in some sense, where the output of one program will become the input of the next. And we'll show you how to do that in the next video.